This is our AI to predict the house prices in Boston by Gabriel Swallow and Charles Dickey. So firstly, wanted to have some initial investigation of the data set. So we checked if there was any data missing, and there wasn't, fortunately. And then we wanted to plot the various features versus price. So on the left is an example of this with LSTAT, just to see if there's the kind of relationships that come up. On the right is a longitude versus latitude heat map where more blue the point, the cheaper the house model, the more red, the more expensive, just to get an idea of geography. We decided to use a random forest to generate the AI to kind of not make the assumption that the different features weren't causally related at all, and let the algorithm determine how they were related. So to optimize the random forest, we visualized, well, you can see a few visualizations here of how the accuracy on the test data varies with max features in each tree, the test size or the proportion, and subsequently tree number, just as a few examples. And we were doing these to try and maximize R squared, but also try and consider overfitting as an issue. We also generated this animation to show how R squared varies with test data. So this is a test data, size of the test data, sorry, as a proportion. In the middle, we see it's fitting nicely to the training data. On the left is the test data. And as expected, the bigger the test data, the less training data, so the AI becomes less accurate. But also, the smaller the test data, the more risk of overfitting we have. Yeah, these are the results with the optimized parameters for the random forest. You got an R squared of 0.88. As we saw before, we did get higher values for specific parameters, but we really wanted to minimize overfitting, considering that we were using a random forest and also the data set was quite small. So we were satisfied with a 0.88 R squared, and we also tried to minimize overfitting. Thank you for listening.